Hello everyone, I'm Fervin, and today we're going to dive into the fascinating world of 3D SLAM using depth cameras. Before digging deep into 3D SLAM or SLAM technology, I would love to talk about depth cameras. Okay, what is a depth camera? So, a depth camera or a depth sensor is a camera which can capture the depth information of object in a scenario. So, through which we'll get a three-dimensional representation of our environment. So, first we'll understand how does a depth camera generally works. So there are three major types of principles which are used for depth cameras. The first one is structured light. So in this structured light kind of depth cameras, there will be a IR sensor which projects IR to the obstacle or to the object which we are gonna get the depth information from. And all these distortions are captured by a receiving camera. So through this IR and the camera's recipient, we can estimate the depth information. The second type is time of flight. So, as the word suggests, time of flight type of depth cameras work work by estimating the time it takes from transmitting to receiving the IR data. So, let's say this is my depth camera, and there is an object placed in front of me at 10 meters, and another one is so 10 centimeters, and the other one is placed at around maybe 30 centimeters. So the 10 centimeter object will obviously take less time than 30 centimeter. So through this variation of time, we can estimate at what location our object or our scenario is. So when you repeatedly take all these values, you will be able to get an idea about or a three-dimensional idea about our environment where we're working. And the third type is stereo cameras. Stereo cameras are similar to our human eyes. So how humans we estimate the depth? Since we have two eyes symmetrically placed from each other, we can estimate at how much distance an object is located. Similar way, the stereo cameras, they estimate the distance at which an object or our obstacle is located through it. And the major applications of depth cameras. First one is industrial automation. Okay. So first, quality control. Okay, there is, let's say, before the automation or the depth camera processing era, and the beginning of computer vision, we had all these machine learning or deep learning models run using normal 2D cameras or a monocular cameras, which gives us only 3D, 2D data. Yes, using a 2D data, you can detect where there is defect in our object or if there is defect in an object and everything can be done using a 2D. But let's consider a scenario where you wanna not just identify where my defect is present in my object, but including that if I could get the exact location at where exactly my defect is present, I can use a robotic arm using kinematics. I can find the coordinate of that exact location. I can pluck out those defect or place that in a different conveyor or do any sort of stuff. So in that scenario, the usage of depth cameras will be vital and robot guidance in manufacturing process. Okay. So as I said about computer vision 2D models, SLAM initial days of SLAM technology used or mapping was done using 2D lidars. So if we talk about 2D radars, yes, they are like very reliable source or a reliable sensor which is used for mapping our location for navigation or understanding our environment. But there is an disadvantage of 2D radar, and that would be desert access information. Yes, you get a good understanding about where every objects are placed and stuff using a 2D radar. But using a 3D depth camera, including the two-dimensional information, we're going to get a depth value. That is, it replicates the vision of an human eye. So you can have an immersive, you can have an better understanding of what or how our environment or the place which you work is. So using that information, the navigation of robots or navigation of any autonomous systems can be done with ease. And augmented reality. Okay. In the recent terms, you would have heard about or known about the rise of Meta Quest, Apple Vision Pro, all these VR era. And whatever animation you see inside the VR is generated using a 3D or three-dimensional data capturing devices like depth cameras. So using this sensors, you can map an area, map an object, or you can map an environment, and that environment can be converted into CAD model or rendered 3D model. So all these models are used inside the VR, AR goggles, used for creating AR, VR games, AR, VR world, Meta world. No, Meta world is one of the most recent and most interesting domain, which is in a boom right now. And our focus and our primary focus of this particular section is SLAM. So for SLAM, depth cameras are very, very because let's talk about the recent craze self-driving cars. So for self-driving cars, you can give the location like you want, let's say you want to reach a point B from point A. But you know, driving an robot or a car autonomously means that you should avoid the obstacles, whatever present here, and the simultaneously you should track the lane at which our vehicle or car is traversing. So to solve all these, we can use depth cameras, and especially the Intel RealSense D400 series depth cameras are very modernized because they're equipped with both RGB data as well as depth information. So let's say you have a model which gets the inform which gets a corner of your road and it tracks. It has the track. It estimates at what is the center point of a road and it follows the track. But your model mm, will never know what obstacle is there in front of your road or where or at what distance your obstacle is, or is there a tree, is there a bump in the road, is there any other obstacle which could affect your journey? No. So in that scenario, the depth cameras or the modern RealSense, the Intel RealSense depth cameras which are equipped with both RGB and depth cameras can be vital because simultaneously you can have your lane tracking as well as your 3D map data, which could be used for navigation as well as avoiding obstacles. Now, now comes the important thing or the major topic of our video that is SLAM. So SLAM is known as simultaneous localization and mapping. So earlier days, when robotics domain or the robots were created, almost everything was remote control. That is, you have a transmitter and a receiver was placed in our autonomous system or our robot, which is manually controlled by a human. Because because before the creation of it, before the understanding of SLAM technologies, we were not able to provide a robot or a system how does the environment looks. So SLAM is nothing but using any sensors or any instrument to map our area, which can be used in the future for any kind of task. Like you can SLAM can be used for many tasks. I mean, the most important thing would be navigation in a robotics, but it can also be used for creating a CAD model out of this point clouds, the 2D point clouds, or either the 3D point clouds created from depth cameras or 2D lidars. So now comparing to a 2D SLAM, the 3D SLAM carries very vital details because since it carries the information about the z-axis as well along with the linear axis, we have information about almost the whole environment, the whole surrounding where we are focused on the area where we're gonna work with. So using this, the navigation task or the task which we want to perform is very much simplified. So okay, to understand and to visualize or to learn about depth cameras and the 3D snap, what I did is I wanted to show a small simulation. So through which we can understand like what or how slam is done or how a depth camera is used in real time scenario. So for this, I just created a random robot. Let's assume yeah, I know it doesn't look like a robot, but just assume that the one which you're seeing in front of you is a robot equipped with. Okay, so to further understand about the depth cameras, I have created a simulation in ROS2 using Gazebo. So the white color box that you see in front of it is an assumed or a created robot with equipped with two wheels and a caster ball and two depth cameras. Was the two red boxes are the depth cameras, which is used for understanding how does a depth camera works. So first of all, what is Gazebo and what is ROS? So ROS is a robotic operating system, which is one of the most famous and very popular framework used in robotics for building control and perception in robotics. And Gazebo is a simulated environment which replicates our real world scenario that can be used for testing our algorithms or other way to understand how a sensor work or how does a robot navigate or perform a task. So I'd love to show a video of how simulation is done. So as you can see, the whole simulation was built in Ubuntu 22.04. And what I did, I started with creating a model, and in that model, which is equipped with depth, it projects depth data from the camera's displays in front. But now, as you can see, the simulated environment has no obstacle in front of it. So the moment when it turn on the visualization part of my depth sensor, we could see that there is no obstacle, so there is no data received by uh, not even received by our robot. But now to understand how depth camera works, I'm going to add a obstacle. So in our case, I'm adding a cylinder. So as you can see, when a cylinder and a rectangular box is added in our environment, you can see that the difference that is in the harvest. So let's say the cylinder is placed at a distance around 30 centimeter and the other place is infinity because there is no information or enough depth value is present for the depth sensor to hit on the object and reflect back to understand or give us an output that there is an obstacle or there is an object that's placed in front of us. So as I drive around, my robot can understand whatever obstacles are present in or around my surroundings can be visualized or understood, or it can be understand how does a depth camera works. Okay. Let's go back to the presentation. Uh, Now we got an idea or got an visualization of how a depth data is viewed using ROS2. Now, is it enough for a robot to perform every task that's needed, or is it enough to navigate through terrains? And the answer would be no. Yes, we got the sensor data and we were able to understand how a sensor works and everything is. But still, for an robot or an autonomous system to navigate, it should have a reference uh, or a map of the whole area in which our vehicle is gonna navigate. Yes, the last simulation which I showed you saw that my depth camera was able to receive the depth data, but that depth data was constructed to only that particular frame. That is, it is showing the depth data of that instant alone. Yes, you can perform computer vision and other models using that particular instant. But for a robot to understand its surrounding and to perform navigation, should your system should be able to collect every frame and update it in a rate to create a whole map out of it. And this map generation is called as SLAM, or more specifically in our terms, three-dimensional SLAM. So in terms of ROS, they have their open source library called as RTABMAP, which is a popular library for creating 3D maps of RGB canvas. So with the help of this, we can generate a map of three-dimensional spaces, which I would love to show another symbols for that. As you can see, to make our environment more complex and to understand the working of a depth camera and 3D slam, I place more obstacle, like I've added few walls and space happen there. So the moment when I start driving my robot, as you can see in the right side, the frames are updated every other second. That is, the depth information is updated every other second to every place that I drive in my simulated environment. So, yes, I'm driving and they said hit a wall and where the twisted map. You can at least see how does the depth simulation works. And once I drive through the whole area, and when I visualize my map, as you can see in this video, the whole environment was created as an 3D map in using RTAP. This is one of such example of how depth camera can be used for performing language and stuff. Okay. I understood how what depth camera is or what 3D scan and stuff. So it would be much better if we understand these core concepts with an real-time example. So recently, like I was working in an underwater robotics project. So our project was to clean the below part of a ship where there is grease, oil, and stuff. So generally, the cleaning process is done manually by humans, like human or divers that dive into it, they clean manually, and it's an expensive and a time-consuming process. So to automate these tasks, what the idea which we came up with was using a depth camera to map the whole area of our ship. Because once we have the map of whole area, we know that we have the reference or the CAD model of how our ship looks. So with that ship, because once you have the map of the object which we are mapping or generating this land, we'll have three-dimensional coordinate system or 3D point cloud. Point clouds is every point, every coordinate of our object or our location. Using that reference with the help of INUs and encoders, we were able to come up with an idea with which you can autonomously do a path planning algorithm like A star to clean the house. So for that task, the depth cameras was very useful, and it was one it was one such good example of how this depth cameras are generally used in robotics. I hope in this video I was able to explain or present you with valuable insights about what a depth camera is, how depth cameras are used for generating slam and stuff. So see you in another video. Thank you.